Short and sweet for you guys. Hello everybody, my name is True, this is Alex. We're both Harvard alums, and we're here representing the team behind Identitrix. So, have you ever been tracked by a bot on Facebook? Yeah. Okay. Have you ever had information that's been compromised through something like Equifax? So the black box of how much information is actually being collected of us and how that information is being used is only sometimes transparent when something horrible goes on. And we're here to change that. We hope to revolutionize personal data protection and monetization through our explicit goal of creating smarter identities in a smarter protocol for a smarter city. Introducing the Identitrix solution, a public blockchain protocol that by its very nature is unprecedentedly fair for all parties involved and fundamentally decentralized with a sustainable and robust token economy. And last but definitely not least, self-sovereign. So what do we mean by that point? Our Identitrix platform allows users like us, not Facebook, not Equifax, and thank God not Cambridge Analytica, to have the control of the exposure of our data, but also to decide whether or not we want to monetize it. And our platform allows us to establish one central smart identity, which allows all kinds of different applications, all kinds of different contexts to be built upon that. And now Alex is going to give a little bit more color on how our technology works.
All right, thanks for an amazing introduction, Shu. All right, so before diving into the deep technical details in our schematic diagram, I just want to give a brief overview of how users engage in the Identitrix network in 3 easy steps. So in our smart city, a new citizen starts the process of joining the Identitrix network by generating an identity wallet on their personal device. At initialization, this consists of a public-private key pair and can be expanded to include personal data and certificates which vouch as a proof of their identity. In the second step, the user formally joins the network by approaching a certified authority. Using the certified authority's own off-chain databases, the user gets the certified authority to digitally sign a certificate, which they can present to anyone else as proof of either their identity or legal requirements, such as them being over 18, living within a certain country, or having a driver's license. In the last and final step, the user approaches what's called a service provider and purchases a service. Now, they can do one of 2 things. They can do what we do now and choose to expose their information to the service provider. Or with Identitrix, they can choose to hide their information and present their certificate instead. What this means is that we can complete verified transactions. Transactions where there are legal requirements, transactions where users have to be within a certain location, while still retaining anonymity of the user and protecting their data. All right, now at this last step, we write all these transactions to the blockchain. Let's move on to the technical details. So over the past 24 hours, we've chosen to work with IBM's Hyperledger Fabric, and in particular, we've chosen to work with Hyperledger Composer, a permissioned blockchain which allows for trusted, certified authorities to issue proofs of identity that are accepted by participants in the network. It also provided a base layer of infrastructure for us. We were able to use this ordering mechanism known as Kafka to get an absolute ordering of transactions, and a consensus mechanism known as simplified Byzantine fault tolerance to reach consensus across nodes in the network for which transactions are valid. Now, what we've done is implement a protocol that wraps all of this, known as the Identitrix protocol. This is a set of procedures which allows users to securely engage with service providers in verified transactions while protecting their data. Now let's see how the process we talked about before maps onto this. Right? So here we have the MSP, or the certificate authority, who has given a certificate to the user after verifying their data. We also have the user going to the service provider and showing a certificate upon a data request. So we can see the flow of data in blue and the flow of certificate in black. You'll notice there is no flow of data from the user to the service provider. Now, for my investors in the room, I know you're asking, what do the token economy look like, right? So how we've designed it is that the user is paid token in order to expose their information when a service provider asks them for their location, for their age, for their date of birth. They have to pay for that. There's a reason why there are data aggregators around today. In return, the user pays a certificate authority for their certificate, and they pay the service provider to accept and enter a contract when they are choosing to remain anonymous. We've also closed the entire cycle of the economy by allowing service providers to also act as certificate authorities when delegated by the network. This means that not necessarily I trust Facebook, but maybe someone I make a lot of regular purchases with, like Amazon, can act as a certificate authority for me when I go to an independent vendor I don't necessarily trust on a smaller site like eBay. So that's how we have chosen to basically generate a very rich and stable token economy. Now, I know that was a lot to take in, and I want to show you guys what it looks like in practice. So I want you guys to meet Joseph.
Hello.
So Joseph is one of our lucky 2.5 million annual tourists to the new smart city of Innova. And Joseph is a smart cookie. He has chosen to protect his digital identity by avoiding those regular booking sites and choosing to book with a smart hotel instead. Let's see what Joseph sees as he tries to book the smart hotel. So we have the app here, and I'm going to give it to Joseph to walk through, and we're going to mirror it on here. So on the right, we see what Joseph sees on mobile, and on the left, we see what the hotel lobby shows him when he enters the hotel. So the first thing Joseph is going to do is choose a smart hotel to book into. The smart hotel is going to expose a QR code for him, which is going to scan with his IDX app. Now, upon scanning, the IDX app is located on his personal device, which has the identity wallet. This means that it can automatically populate the forms in the app. Now, Joseph has one of two options. Here we've shown that he can choose to expose his data to the service provider in return for IDX token. Joseph has another option though. He can choose to hide his data. Instead, Joseph is going to present a certificate to the service provider. In return, he has to pay the provider IDX token for entering into a contract where they don't necessarily know the party. He's going to authorize it now. So now he's sent out the certificate to the provider. The provider knows that he's a model citizen, enters into the contract with him, finalizes it, and bids him a great night's sleep at the smart hotel. All right, so I think that wraps it up for what it looks like on the front end. Now, I want to emphasize that we are not just another underfunded DApp. What makes us special is that we are building a protocol here, and we've relied on the Hyperledger Composer infrastructure to really provide an ecosystem for other DApps that exist in addition to the sample one we've demonstrated here. So over the past 24 hours, we've modified the Hyperledger Composer network. We've added some specifications for who participants can be, such as identity owners and service providers. We've added assets such as making booking. And now here we've exposed a REST API server where users and developers can enter into protocol calls in order to interact with our network. So you can see that here. What we've also done is expose an Angular server, which allows even easier development of not only DApps, but web apps. You can just know about web programming and interact with our blockchain, which is amazing for uptake. So here, again, we have the same functionality as the RISC API server, but we can see here that there are some already existing entries. So for participants, we have me, we have Joseph, and we have someone who's really interesting with an email, oops@equifax.com. We also have assets. Assets on our networks so far include bookings at hotels and various service providers. We also have transactions, which record the history of our blockchain. So I want to really emphasize here that Identrix is looking to really serve everyone in this smart city. We're not only looking to target people who want to book a smart hotel for a night. We want to make sure that people feel secure in this smart city. And they can feel secure because they know that their identity is protected by themselves. I'm going to hand it back to Shu.
So join us, whether it would be to partner with us, invest in us, and participate in our ecosystem as users or as developers. And together, let's make smart identities into the fabric of smarter cities. Thank you very much, and we'll take some questions now.
Fantastic. So you did that 10 minutes, and that's perfect. So we have, any judge have one question? Yes.
Which portion?
It's showing his experience.
That's a mock.
The mock-up.
Yeah.
So everything else
But the back end is functional.
So basically, we have a functioning web app which accesses the curl commands to basically interact with the REST APIs that are exposed. But the app part, we didn't have time to do it 24 hours. So this is a mock-up, so it doesn't exactly interact with it, but that is a completely functional.
So for all of us, we learned hyperledger code in the last 24 hours.
24 hours.
And we figured that connecting the REST API is something that is pretty easy for a lot of people very familiar with web development. And learning the blockchain side would be the most exciting part for us in the past 24 hours.
Thank you so much. Any other questions?
Yeah, I got a question. One question. Actually, what if somebody who like verify my identity will sell my identity because it's kind of cost too much because I can build a copy, clone identity and go for the.
So you're saying what happens if someone tries
Yeah.
to sell your identity?
I mean, I trust to verify my identity, but they steal it and sell it. So and make this identity in your network by the protocol.
So I'm having
And verified,
where you
and,
see
and mine is not verified.
For example, when I share the information with you,
Yes.
as a service provider, you actually already got the information, and you have a public key. So later, you can resell this information to other people. Because basically, it's public key, it's matched to your.
I see. So we're talking about sharing the certificate, right? Instead of sharing the public information and saying, why can't I go around as a service provider, take your certificate and your public key and show it to someone else? And what we've done here is, we've said that the certificate authority, and quite a few other blockchains do this as well, set expiration times and expiration uses on certificates. And that means that you can't reuse them.
No, you cannot reuse, but you can use the data to make the certificate, and instead of my identity, give to somebody identity and fake identity and make a fake identity.
So the way we've designed this is that your personal data in this ecosystem stays on your personal device. Right? It doesn't leave your personal device. So I don't see where you're
people
finding
clone the devices. So
I mean, we can talk. I know you guys.
Yeah, we're running out of time, but we can.
Thank you.
When we're talking about security, right? Like we're talking about like wallets and with cryptocurrencies, someone can always steal your wallet. When we talk about security, it's more about managing everything in your personal, on your personal device. Thank you.
Okay, thank you. We have a heated discussion here. So next our team is healthcare, and the team.